Yo, advanced geometry students, Mr. Donaldson again. I know you love the sound of my voice. You're excited to watch this next video here. This one's on geometric probability. But before we get into that geometric part of it, let's just kind of build on some knowledge that you already hopefully have. And that is what probability is. I'm sure you understand the probability. I hope you understand, I should say, the probability that when you roll a single die, what's the probability you get a 2? Well, that probability would be 1 out of 6. Now, here's why. Probability is the favorable outcome. The outcome you're looking for. In my last example, that'd be getting a 2. Divided by the total number of possible outcomes. And in the case of rolling a die, that is 6. So if I wanted to know what's the probability, I'd roll a 2. Well, the answer would be that there is one favorable outcome on that die. There's only one way to roll a 2 out of 6 total outcomes, which gives me a probability of 1/6. Or, as a percentage, you do that in your calculator, 1 divided by 6 is about 0.167. Or about 16.7%. When we're doing probability, geometric probability, I'm going to ask you to give answers as fractions and as percentages. And to get the percentage, you'll simply divide the fraction of your calculator and then multiply it by 100 to get the percentage. Let's take a look at an example here. So, in this example, we have find the probability that A point chosen at random from the circle below will be in the shaded area. Give your answer both as a simplified fraction in terms of pi and a percent. So y'all, what I'm going to do is I'm going to kind of show you how we make a plan and we attack this thing very systematically. All right? So here's my plan. My plan is for geometric probability to find the area of the favorable region. So I'm just going to write favorable area divided by the total area. And then I'll come up with a plan to show, conceptually how I'd find those areas. So the area of the favorable region there is just the shaded area, which is everything inside the circle except for that rectangle. So that favorable area is the circle minus the rectangle. Now that circle has a radius of 5, and the dimensions of that rectangle are 6 and 8. The total area, it says a point chosen at random from the circle. So the total area is the entire circle with the radius of 5. So the area of a circle is pi r squared. So I do pi times 5 squared minus the area of a rectangle is base times height, which in this case is 6 times 8. So that numerator in my fraction there represents the area of the shaded region. I got the area of the circle minus the area of the rectangle. And the denominator of my fraction for probability will be the area of the entire region, which in this case is the circle. So that's what I need to crunch, and that will give me the probability. So let's take a look at what that is. On top, we're going to get 25 pi minus 48. And on bottom, you get 25 pi. Now you all, 25 pi and 48 are not like terms, so I cannot combine them. This is the probability in simplest form in terms of pi. The next thing says is to find it as a percentage. Now, when you find the percentage, it's really important you understand how to put this in your calculator by following the order of operations. So my suggestion, before you put it in the calculator, put a parenthesis around the numerator and the denominator individually, and you won't get it wrong. All right, so let me just punch this in my calculator. I've got 25 pi minus 48 in the numerator, in parentheses, divided by 25 pi in parentheses in the denominator. And I get approximately 0.388. So I've got about, well, let's go to one more, 0.3888, which is approximately 38.9%. Is the probability that a point bouncing around inside of that circle at random would be in that shaded region. And you all, the importance of using that parenthesis when you are doing your division with that fraction is because suppose you were doing this, for instance. Let's say you're doing 10 divided by 25 pi. If you just type that in your calculator as 10 divided by 25 pi, your calculator is going to divide this first and then multiply that by pi. But you want to divide the entire thing by 25 pi. So just be careful. Use a parenthesis for the numerator and the denominator, and you won't make mistakes. All right, so we're just going to do 2 more examples together. This shouldn't take too long. And then from here, you'll work on the rest of this worksheet. You can check your answers by checking in the filled-in version on Schoology. So in this case, my favorable area, there's nothing to subtract this time, so be careful. Don't overcomplicate things. All right? I've got the favorable area over the total area. Well, the favorable area is just those 2 circles. Those are the only things that are shaded. Divided by the entire area is the square. Now, the square, just to make sure that I have the same units, right? The diameter of each circle is 4 inches, which makes the radius 2 inches. And then, in terms of the dimensions of the square, let's just go ahead and make common units. So we're going to make that 12 inches instead of a foot. So 12 inch by 12 inch. So, now here we go. This is 2 times pi times 2 squared divided by 12 times 12, which gives me 8 pi over 144. Now, I can simplify that because 8 and 144 have a common factor of 8. This is the same thing as pi over 18. So that is the simplified form. And now if I want that as a percentage, I'll simply divide pi by 18 on my calculator, and I get around 17.5%. See, on this example, when we did our favorable region, there was nothing to subtract to get the shaded area, so just be really careful. That's kind of a common mistake. People tend to overcomplicate these problems. So just think, what's the area of the shaded region divided by the total possible area? Now, example 2, you'll notice that this little petal thing looks very similar to that last worksheet that you did. So remember, in order to find the area of that petal, here's how I'm going to break it up. What I'm going to do is I'm going to find the area of this entire sector. So this entire sector. And I'm going to subtract from it this triangle. And when I subtract that triangle, what I'm left with is half the petal. So for my favorable region, the way I'm going to find the area of that petal is to find the half petal, I would do the entire sector minus the triangle. But that would only give me half the petal, so I would need to double it to get the entire petal. So this is my plan. Because what this is 2 of these little half petals divided by the entire square. So that's easy enough. That's just 12 by 12. And then in my diagram here, that's 12, that's 12, that's 12, that's 12. So here we go. So I'll show my work down here. This is 2 times. This is a quarter. That sector is a quarter of a circle with a radius of 12. Minus, we got a triangle, and the area of a triangle is 1/2 base times height, divided by the entire area of the square, of course, is 144. Now, it looks pretty gross, but it's not going to be so bad. This is 2 times 144 divided by 4 is 36. So this is 36 pi minus half of 12 times 12 is 72. All of that over 144. And then we'll simplify one more time. I'm going to distribute my 2 here. So I get 72 pi minus 144 all over 144. Now, in terms of getting your answer as a fraction in simplest form, this is something you may recall from algebra class, but all 3 of these factors all three of these terms in this expression, they all have a common factor of 72. So what I'm going to do is I'm going to divide each of them by 72. So this would give me 1 pi, or just pi, minus 144 divided by 72 is 2, and again 144 divided by 72 is 2. That is the answer in the simplest form. And then to get it as a percentage, I'll divide it in my calculator. So I got pi minus 2 divided by 2 gives me approximately 57.1%. So you all give that a shot. If you have questions or need help, of course, come see Ms. Butler. And thanks for listening. Hopefully that wasn't too painful. Have a good day.